Hi, Kat here for Lightwave Digital. In this video, we're going to be talking about turbulence FD inside of Lightwave 2023.01 and the use of forces, including pressure. Here we have a simple setup where I've got a cube that's basically 5 meters by 5 meters by 5 meters. That is our volume container, and we've got two simple objects inside of it. One is going to be emitting fluid as a density channel, and the other one is not going to be emitting anything, but it's going to have various values applied to it that will impact the density channel being emitted by this object. So just scrubbing through the timeline here, you can see a really nice example of what that effect is. But you'll notice that there's no other fluid being emitted from this simple plane to cause that interaction. And it's achieved through the use of forces. So let's take a look at these emitters, see what they're doing. Here's our elongated box. Nothing really special going on here. There is a little bit of pressure just to help initially kick off the density channel as it's being emitted. It's set up as a collision object. And it has a texture of 1 meter with 1, 1, 1 for octaves, contrast, and speed. This gives us a little bit of breakup on the emission of the surface of the object. But other than that, it's just a density of 1. So that's all that's happening on this object. Now this simple plane, as you notice, is animated. It goes from 0 to about frame 42 towards the box that is emitting density. The reason why I did that is to show that at a further distance away, the effective pressure and force from this box has a direct relationship to this box and its density being emitted from it. So let's take a look at how that's being achieved. The simple plane doesn't have anything on it really except for texture in the surface texture channel. This surface texture channel setup is very simple. It's similar to how I would do something with a fuel mask or other type of setup where I want to have the emission from a surface be in a specific spot using a UV map or just through a procedural texture. This is no different, except we're just using a turbulence surface texture plus a value behind it so that we can break up how much of this is being kicked off, not in terms of fluid channels, but in terms of force and pressure. So with a normal force of 1, we'll see a difference when we calculate this again. You can see that the density is being pushed off the cube as the simple plane gets closer to it. But it doesn't seem so drastic. It's breaking up a little bit less than before. The reason being is that the simulation is not evaluating accurately enough based off of that pressure value that I had originally, which was 5 times higher. Normal force setting. Okay, so I think we get the point there. Let's just scrub through this and we can see that coming off there. It looks very good, but it starts slowly because of the proximity and the fall off being closed up for how that pressure is being emitted. So to improve this, let's go back to our emitters. We can go back to a normal force of 5 and go back to our container. And under simulation, we can increase both the subframe steps or the pressure iteration limit. Let's try with a better iteration limit and see if this improves the look of how things are coming off of there. Let's hit start. we can definitely see that this is improved, where it's less steppy coming off of the front end of the object. And we get a more drastic effect of the fluid being emitted, and it's more broken up, in part because of the force that's being interrupted by that texture that's running around the surface of this pressure object. So getting that less steppy effect is a combination of frame substep limits and pressure duration limit. We can probably split the difference on something like this. And get a faster calculation with a better result by just increasing the frame substeps. Let's go to about frame 60 here. Let's stop. All right, so again, much improved. It's a little bit steppy, but by playing around with these values, you can get a much smoother result. But you got to remember that you may not necessarily need it once you do go in and do final shading with the density shader or the temperature to fire shader or whatever it might be. Now, this can work effectively in a form of reverse, but the results can be a little bit unpredictable because of the way that this texture is applied to this object. And we can turn this into a vacuum effect rather than a pushing effect. So let's go to our emitters again. Here's our simple plane. We're going to change the pressure to minus 10,000. And we'll go minus 5 for the normal force. So this should effectively create a vacuum. You know, it's getting a little chewy in here because, again, we don't have enough subframe step limits. Well, once it stops moving, it kind of smooths it out. But if it does look a little bit steppy, you're going to have to increase the frame substep limit. That'll help smooth out the emission and its movement over time. Because you can literally see the steps. It's 1, 2. 1, 2, plus a little bit more. Depends on which frame you're at. But you can definitely see it being steppy. Again, might not be too much of a problem in your case, depending on how you're shading this. But if you find that it's becoming a problem with artifacting, there's your solution. Now, there's also the fact that you can pretty much obliterate the pressure completely, and this should simulate quite fast. But without any type of value for pressure, you're not going to get much in the way of movement at all. So even just a little bit of pressure will help encourage that normal force. We should set this to a negative value. closer it gets. Even as slight as it may be. It will start to drag that fluid off and pull it towards the object that's acting as effectively a vacuum. Let's try again with a higher value. Or a deeper value, so to speak. Let's go minus 100. All right. Let's try it with a minus 1000. There, the action on the density channel being manipulated, the elongated box is quite present. So there's a threshold based off of the amount of pressure, normal force, and of course the distance that the object is from what's being emitted for a fluid channel. So these are a very delicate relationship, but playing around with them can definitely get you somewhere very, very quickly. Now let's talk about one more thing here, and that is velocity weight. This is a very interesting value. We're going to just set this all back to kind of normal defaults here. Go 10. Actually, this can be 0. We're going to give the velocity weight to the elongated box because that's what's emitting the fluid. Let's give this velocity weight of 10. Let's see what happens here. Velocity weight is essentially a value that tells the fluid that it has a certain amount of oomph once it starts going in motion. I think we're going to have to turn some things up here. So we'll turn the plane pressure up. The direction for that. So let's start this. So this is going to kick it off the other direction now because it's no longer working as a vacuum. Well, it may cause the fluid to move more slowly because it's got more weight to it. It's going to behave very differently once it interacts with other objects in the scene. It's going to be like a thicker, denser smoke, like it's almost made out of goo. You can do lava effects with this, like in a lava lamp. It'd be great for working with starships and pulling them out of like the Numatara Nebula, like in Wrath of Khan. Those types of effects. So you can see just how much this is kind of stuck together without falling apart. It changes the behavior of the fluid entirely because it's acting more like an actual fluid rather than a non-compressible gas. Let's crank this up a little bit. And one of the other things we're going to do is we're going to close the X barrier on the container so it acts like a wall. So we can see what's going on the wall. So we're going to go over here and just see which axis that is. It's a minus X boundary. Okay. And we're going to crank this stuff up really hard. $1,500 for that. And we'll go 25 for that. Let's go 25 for velocity weight, and just see what kind of wild wacky effect we get. Let's zoom back in here. So we can get a better idea of what's going on. And let's start again. To see just how different the behavior of the fluid channel is now. If you want to do ethereal ghosty effects, sandstorms, crashing waves, the mist that comes off of them. This is a input value you can play with to achieve such effects. It helps make that emission channel thicker in terms of how it moves in response to outside forces. Still remaining inside of the container volume, of course. Okay, we'll go to 90 frames. We'll zoom out a little bit and see what this looks like just for a quick review. So very different from what we had before, all by just changing a couple of values with respect to the velocity weight and our normal force and our pressure on the disturbing object. I like to call them disturbing objects because it's disturbing the fluid that's being emitted off of another object. All right, well, I hope you enjoyed that section of these videos on Turbulence FD and Lightwave 2023. We'll have more in the series. Stay tuned.